Good afternoon all, and in the last lecture we have seen about the threads. Okay, in just a 5 minutes we will overview the threads, and we will go ahead for the different process related commands and how we can execute it on the Linux platform. Okay, that we want to see in the today's lecture. So first of all, we will take the some overlook for the threads that we have discussed in the last lecture. Somehow it is not recorded, so I am just reviewing it. A thread is a basic unit of the CPU utilization, and thread is with each thread the different parts are associated. That is nothing but the code, data, files, register, and the stack. Okay, in this diagram you can see that every thread in the single threaded process, you can see that the one thread is present, and for each thread there are the code, data, files, registers, and stacks parts are present in every thread. When in the multi-threaded process, when there is a multi-threaded process, then for each thread the code, data, and files are shared between the different threads, and the registers and stack are the having for each thread we are having the separate registers and stack for the processing. So this is the definition and idea behind the thread. The why we are going for the threads, the when the thread is a lightweight than the process creation is a heavyweight, whereas the thread creation is a lightweight. So simply creating the different processes, either we can go with the creating the different threads within that process. Then we have seen the two examples for the creating the threads. That is nothing but the one word processor, and that word processor can at a time it can be work for the update display, then fetch data, also for the spell checking and answer a network request also. Then another example we have seen that the multiple clients can access the server at a time. Then server, for each client request, the server is going to create a new thread, and again it is going into the listening mode for the serving the new request comes from the client. So these two examples we have seen for the threads. Then we have discussed also about the benefits of the threads. That is nothing but the responsiveness, then resource sharing, and economy and scalability. Means responsiveness means when one of the process is blocked, then easily we can uh, yeah, we can continue with the another thread. So that is nothing but the responsiveness. Then resource sharing, the multiple threads can share the different resources. So that is the another benefit. Economy, it is a better than the creating the another process, so it is a economical because of the process handling. Many process handling can cost for the context switching concept, so it is a less overhead between the switching between the threads rather than switching between the processes. And then the scalability, the another benefit is the scalability, means we are having the multiprocessor architecture, so at a time we can serve the many request at a time. So that is nothing but the scalability. Also, we have seen what is meant by the multi-core and the multi-processor systems. These are the some challenges between the multi-core and the multi-processor system. That is nothing but the dividing activities balance between the doing the task. Data splitting means many core requires the same data sets at that time. Data splitting should be there. Then data dependency, one process can require the data of the another one, so data dependency we have to deal with the multiprocessor system. Then testing and debugging also. So there is a difference between the parallelism and the concurrency that we have seen with the use of the diagram. Then there are the two types of the parallelism. First one is the data parallelism, and second one is a task parallelism. The data parallelism deals with the uh, distribute the same subsets of that same data within the multiple cores. When one database is going to be divided and shared within the different multiple cores, then that is nothing but the data parallelism. And what is meant by the task parallelism? When one process is there, we are dividing into the different threads or the task, and we are distributing over it over the different cores, means with the different processors. So that is nothing but the task parallelism. Then there is a difference between concurrency and parallelism. You can see here, that is the when we are having only one single core, that is nothing but the concurrent execution. T1, T2, T3, T4, and again T1, T2, T3, T4 is going to be invoked by using the round robin algorithm or the time sharing system. After the some time, the another task is going to be called, then another, and so on. So that is nothing but the concurrent execution. And what is meant by the parallelism? On a multi-core system, we are having the different processes, and separately we are executing the task. And that you can see here, that is the T1 and T3 can execute it on the core 1, and T2 and T4 can execute it on the core 2. So what is the output of this one? Efficiently we can complete our task in less time. So that is nothing but the advantage we are having, more advantage we are having in the parallelism. Then this is the diagram we have seen for the introduction of the threads. Then there are the two types of the threads are there: user threads and the kernel thread. The threads which management or the invoking is done by in the user mode, that is nothing but the user threads. Examples, that is the POSIX, Windows, and Java. Whereas in the kernel mode, all operating system threads are nothing but the kernel mode, we can say. So these are the two different types of the threads. Then we have also seen the multi-threading models, that is the many to one to one, and many to many. These three models you have to remember, because of in many question papers this thread model and their diagram is going to be asked. So remember these three things, that is the different types of the multi-threading models, that is the many to one to one, many to many. The diagram for many to many, when there are the many user threads are present and the only one kernel thread is present, so simply we can say this is the many to one architecture, and these all threads are mapped to the one kernel thread. Then in one user thread is there and it is going to be mapped with the only one kernel thread, then that architecture is nothing but the one to one. Then many to many user threads are there and it can be mapped with the many kernel thread, mean any of the kernel thread, then that is the many to many. And when multiplexing concepts are there within the two or more user threads can mapped with the one kernel mode, and then that is nothing but the two level mode. So this is up to the threads in your syllabus they have mentioned, and we have completed the all concepts related with the thread. Just like a creation of the process, we can also create the thread by using the different system calls. No issues within that one. So there are the different thread creation system calls are there, and simply we can, by using that system call, so we can create it. But all the creation and the handling of the threads are not mentioning in your syllabus, so we are not discussing it. So up to this one, in last lecture we have discussed about the synchronization between the different processes by using the critical section, then semaphores, mutual exclusion. These all the things, concepts we have seen into the last lecture. And also today we have revised the thread, all the points related to the threads. So now we will go to the next point from your syllabus, that is nothing but the executing the different process related commands. Which are the different process related commands are present on your Linux system, and how we are going to perform it on the Linux operating system. So for the in the practical number 1 we have seen that how we are going to install the Linux operating system, and on that Linux operating system we want to execute these all the commands on the Linux platform only. When you are going to do it on the Windows platform, you will simply get the errors, because these all the commands are related with the Linux platform. You can use the any online platform to execute these all the commands, but it is better to install the Linux, and you can you can easily perform these all the commands. So the first command related with the process related command is nothing but the PS, that is nothing but the process status. So what is the output and how we can execute it? Just in the slide you can see that this is your terminal. Okay, all of you have seen the terminal, or simply you can tell this as a current shell, and on that terminal you have to give the PS. Okay, and when you hit the enter, you will simply get the output as the PID, TTY, time, and CMD. Okay, just a minute. हॅलो.
हॅलो.
हां बोला. हॅलो.
हॅलो.
हां हॅलो बोल.
सर लेट झालाय तुम्ही.
ओके ओके जॉईन हो जॉईन झालो मी बघ. हॅलो, ऐकू येते सगळ्यांना?
हो सर.
ओके, कुठंपर्यंत आलेलो आपण?
स्टार्ट केलं लगेच व्हायचा याचा बंद झाला.
बर, आता येतोय ना?
हो सर.
ओके ठीक आहे. तर आता जे आहे जस्ट आय हॅव रिवाइज्ड up to the I have revised up to all the concepts related to the thread, and we have recorded also. So I will simply put the that video on your group, and you can see that later. Just at the last lecture, we have all the points are reviewed in the today's also. So first of all, this is nothing but the PS command. Swapnali, can you hear me?
Yes sir.
Okay, the first command is the PS command. The PS command stands for the process status.
स्क्रीन शेअर केले नाही.
Just a minute. Okay, it is visible now.
Yes sir.
Okay, the first command is the process status. Okay, how you can going to execute it by using the terminal of the Linux platform. Simply you can go to the terminal of the this one Linux, any kind of a Linux platform, and simply you can type the PS stands for the process status, and when you hit the enter you will get the all the processes running on your system. Means PID is nothing but the process ID that are running on your system, and then TTY is nothing but the terminal type. Means there are the different types of the terminal present on the your Linux operating system. Simply you can take this as the zero terminal, and then the time and the which command you have executed that one. So that is nothing but the this is the unique process ID, then terminal type, the information, the amount of CPU in minutes or and seconds that has been processed has been running, how many times it is going to be run on your CPU. That is nothing but the here it is looking at a 0, because in some kind of a fraction this command is going to be executed, so it indicates as a 0. And then CMD, name of command that launched the process. Okay, so simply by using the PS command you can see which different types of the processes are running on your system, and the PID indicates the process ID. For each and every process on the Linux you are having the process ID, and that we can see by using the PS command. Then we can see the next command as a kill command. Okay, now we are taking the overview for the last point of your of your chapter, that is nothing but the executing process commands. And first command is a PS command, then second command is a kill command. Suppose I want to terminate any kind of process, then simply I can use the kill command. Kill space and process ID, then that process is going to be killed out. Or the another use of the kill command is nothing but the sending the signal to the process. So that is also done by the kill command. How you can do it? So simply here they have given the example. Okay, by using the PS command you can see the different processes that is present on your system, and by using the kill PID, okay, here you can see in this slide kill 6056. means this process is going to be kill. Means suppose I want to stop any kind of a process, then simply I can use the kill command. Then kill minus s is used to send signal to the processes. So that is nothing but the here you can see minus signal or minus s signal you can use, and the PID to sending us some signal to the process. Okay, that for that purpose also kill command is going to be used. And when I want to represent that all the signals into the table format, then simply this command is going to be used. So the use of the kill command is nothing but the killing the process and to send signal to the any one of process. So that is nothing but the use of the kill command. Then we will go for the sleep command. The sleep is the another command that is used for the process. This is the another for the process related command. And when we are using the sleep and then the timer, so that is nothing but the waiting for the 2 seconds. Suppose I want to stop CPU processing for the some seconds, then simply I can use the sleep 2. Means after 2 seconds you will get the message as the task completed. Okay, so this is nothing but the shell script. Okay, in the Linux platform we can write down the shell script to uh, complete the any kind of the basically the shell script is generated for the uh, executing the number of commands. Means suppose first of all I want to go into that directory, then I want to simply copy one file into the another, then I want to edit that one. So these are the sequence of the commands I want to execute into the one go or at a time. So for basically for that purpose the shell scripting is generated. But in nowadays the shell scripting does the all the system programming is done into the shell scripting. Just like your C programming, you can use the if loop, you can use the print statement, any kind of a logic you can develop into the shell scripting. Okay, then this is the example of the shell script. Okay, the first line indicates the which type of the shell it is using, that is nothing but the bin bash shell it is using. Then echo is same as your printf statement, waiting for 2 seconds. Then sleep we have used to stop all the processing for 2 seconds, and after that we are printing the task completed. Means suppose I want to uh, stop the processing, or I want to delay some kind of a delay I want to generate in the processing, then I can simply use the sleep statement. So we can take the different examples of the sleep statement. That is nothing but the yum indicates for the uh, minutes when there is a 0.05, that is and when we abbreviated it as a yum, then that indicates the minutes. Then suppose when I want to define the time into the hours. Hello, Swapnali.
हाँ सर.
Okay. Okay, when I want to declare the time into the hours, then simply I can use the 0.003h, that is nothing but the hours. So in the seconds, minutes, hours, we can define the time. So now we have completed the ps command, kill command, and the sleep command. So the two commands are remaining. The first one as a wait command. The wait command is used to wait for the some process to complete. Okay, and after completion of that process we will start it again. So waiting for the some process to complete in the fork system call also, when we are using the fork system call to when I want to wait for child to complete, then I can simply use the wait as a wait system call there, or the wait command there. When wait command returns the 0, means it successfully completes the all the child processes. And when I will get the one any digital number between the 1 to 126, so that is nothing but the some erroneous thing is happening to that one. So this is the, with the help of the scripting we will see the function of the wait command. So the first one is about the testing wait command. and the and sign. So what is mean by the and here? This echo testing wait command, echo is nothing but the printing command, just like your printf, and when I want to run it at the background, then that is nothing but the uh, define it by the and sign. Then process id is equal to dollar and exclamatory mark. So what is the meaning of that one? Is nothing but the when the process id of earlier process, means echo command process is executed, is assigned to the process id. Process id of this echo command is assigned to the variable process underscore id. So that is the meaning of the second line. Then again we are running the different command, and we are waiting for the first process to complete. Wait for which process? The first process to complete, and later that we are just echoing or the printing the job one is exited with this status, and again wait for the another one, and again here the job 2 is exited with the status 2. Okay, means here we are waiting for the first process first echo to complete, and then we are printing the another one. So this is the example for the wait command. What is the use of the wait command? Wait command waits for the some process to complete, and then again we can resume the another one. Okay, so this is the output of the wait command. Testing wait command 1, then testing wait command 2, job executed. Means first of all we have to execute the command 1 here, and then we are going here for the wait command 2. Then there are the different examples also. Here also you can see in this scripting, the sleep command is used for the 20 second, and after that 20 second the again uh, the PID is assigned to that one, and here also wait and kill system calls are also used. So these are the different scripts we can write for the understanding of these all the commands. You can simply remember the all the meaning of these commands, and how simply one script to the one script is sufficient to describe the information or the concept behind the any one of the command. Then next one as exit. Suppose I want to exit from the prompt, I can simply type the exit and enter. You will your terminal is going to be closed. So that is the use of the exit command. Also the exit command is used to set the return status. Means suppose uh, I want to return something to the parent process, then I can use the simply any number, that is the if exit 110, and I am going to hit the enter, then that is nothing but the when the parent process or the wait is there for the that process, then that wait command will get the status as a 110. So that is the another use of the exit command. So these all the commands, ps command, then exit command, kill command, sleep command, and wait command. So these five commands are related with your process management. So we have completed this one. If you have any kind of a doubt, then you can ask now.